Hey, 8th grade. So today's try it problem was talking about a door swinging open and it gets to 85 degrees but gets stuck. Thomas pushes on the door and it opens some more. The door opens 100 degrees in all. How many more degrees does the door open after Thomas pushes it? So in our notes we talked about we could visualize it, and that when we're visualizing it, it could be a sketch, so these degrees don't have to be perfect. It's just letting us know what we do know. So like on this one, we could sketch what we think is about 100 degrees, right? The fact that the first push is 85, and that gives me my first angle, and then my second angle, how much further is it to get to the 100 degrees? So we could draw the situation for ourselves. We could model it. So if we're looking at a protractor, I can sit here and go, okay, well, I know that the first one got me to 85. I know I end at 100, so how many is between 85 and 100, and then solve it from there. So those are a couple of ways we could solve the problem. So then we started talking it out. And so it said, write a sentence that describes how the unknown angle measure is related to the 85 degrees and the 100 degrees. And so we wrote, the unknown angle measure is the difference between, or of, so the difference between 100 degrees and 85 degrees. Remembering that difference means that we subtract. So does addition or subtraction best express this relationship? And since we said difference, that means subtraction is the best representation. So then if we write it using these images and we write out an expression, that's going to be 100 degrees minus 85 degrees equals 15 degrees. And that's how we're going to solve our problem. And then it asked, how would a measure of the unknown angle change if the door opened a total of 120? So if we're looking up here, that would be making this, like adding 20 to this 100. Well, what we know from algebra is what I do to one side of the equation, I have to do equally to the other. So our answer will increase by 20. That being said, that means that where we're doing this, adding 20 over here, right? Here's our original equation. 85 equals 15. If I add 20 here, I have to add 20 here. So then I'm going to do 15 plus 20. It opens another 35 degrees, because 15 times 20 is, or not times, plus 20 is 35. And then it says, imagine an angle that is composed of 3 smaller angles. You know the measure of the composed angle and the measures of 2 of the smaller angles. Explain how you could find the third angle. So again, if I sketch, if I make myself a sketch here of an angle, right? Not a pretty sketch, but I'm making a sketch. And I split it so that there are 3 angles in here. I'm not trying to make them even, right? Any 3 angles. So like I can turn this one this way, right? Definitely not 3 equal angles now. If I know the total, the composed angle, and I know 2 of my other angles, how do I find the third? And so the way we talked about that is we can add the 2 smaller angles and then subtract from the composed or bigger angle. Oh, ran off the screen. Okay, so we're going to now do a couple of these so that you can see. When we talk small and big angles, when we're talking about finding missing angles, I refer to small angles as the angles composing the bigger angle. So we're not thinking of small angles as only acute angles and big angles only as obtuse. The big angle is my final angle, right? The whole angle with all of them. The smaller angle is whatever angles compose the bigger angle. All right, so looking at our apply it. We have a game that includes an 8-second timer as shown. At the right, the timer's pointer turns through 135 degrees as it counts down from 8 seconds to 5 seconds. How many more degrees does the pointer have to turn through to complete a full 360 degree circle? So I know that I have a big angle at 360 degrees. I have a small, and this is what I mean like big versus small. Small angle meaning it's part of our big angle, makes up our big angle of 135 degrees. So because I have a big and a small, and I'm looking for the other small, then we're going to subtract. So 360 minus 135. That's going to give us, that's a 5. This becomes a 5. 5 minus 3 is 2. 3 minus 1 is 2. So our solution is 225 degrees. So now when I look at this next one, a snake's mouth opens to form a 180 degree angle, which is a straight line. The snake then partly closes its mouth to form a 60 degree angle. What is the difference between the measures of the angles formed by the snake's open mouth and partially closed mouth? So here's my 180. That's my big, right? That's as far as he can open his mouth. He can't open it any further. So our big angle is 180. Our small angle is 60. And it wants to know what degrees are now left out. So we're going to do 180 minus 60, which is 120 degrees. So our solution is 120 degrees. All right, lastly, we have the diagram here shown at right. The bottom line is a straight line. Write a solution, write and solve an equation that can be used to find the measure of angle M. Show your work. So, very important, tells us we have a straight line. So that means that from here to here is 180 degrees. Okay, so I know I'm starting with 180 degrees. And I'm going to subtract from it, because that's my total, and I'm trying to find this small angle. Now, this is an example of that question that we had on 5. What happens if we have multiple angles and I'm finding one of our missing small ones? So we're going to add them up. So I'm going to take 38 plus 51 plus 42, and I'm going to add it up. And once I find their sum, then I will subtract from 180. Since I know I want to add first, I put them in parentheses. Here is one long equation, right? And I don't know this answer yet, so I'm going to call it x. I am solving for x. So I'm going to start by adding. 38 and 51 is 89. And then we're going to add 42 to that. So 9, 10, 11. 8, 9, 10, 11, 12, 13. So now I'm at 180 minus 131. And when I do that subtraction, we end up with 49 degrees. But notice, I added and then I subtracted. Do you have to? No. We could have done 180 minus 38 minus 51 minus 42. We're going to end up with the same thing. So, those are our notes for today. If you have questions, please ask, and I will see you in class. Have a great night.